Um, continue kind of building, uh, you know, properties up. Properties. So we're on page 8. We finished page 7, right? We finished all. So all the odds. So I'm just gonna work through these practice with you. And, that's okay. So one, tell whether or not sign X identity. All that means is somehow convert this fraction to work out these. Just with previous strategies that we talked about, where if I don't see some sort of sine and cosine, let's just convert everything that we see into cosine. So what can we do with it? Can turn into over secant can be written for cosine. So it's like a pretty ugly complex fraction, but we know we can always make a complex fraction by moving the denominator. Okay, so keep the sine over cosine. We'll flip that one over cosine to the top. So dividing a fraction, let's multiply. And goes away. So sine is an identity because this does clean up to be. Sometimes the difficulties of these problems is kind of blindly just trying different things and hoping that something will start working out. So here it says prove the following identities. Okay, so this is how typically we're going to have to work these problems. Only work from one side of the equation. That means you can't work on the left or work on the right and find a way for this. Either you start on the left, clean all that up to make it look like the right side, or you start on the right side and work on that into the left side. So we're not going to can't we can't involve both sides. We can't work both sides and equal to one of the. So usually, okay, usually we're going to start on the left side and move to the right side. Usually, our strategy is sometimes we go from the right to the left, but typically I would say that's right. Usually, we want to start want to work with complex. That's kind of, so for number 2, um, I'm going to think that it's a little bit. We're going to work practice starting on the left side. I'm going to try to get that left side, hopefully clean up, eventually turn up to look like. So the first thing I see is, well, I'm going to start getting rid of some parentheses and seeing if I can distribute that sign through. But actually, before I distribute that sign through, I'm looking at my goal. Goal is to sign. So why don't we start converting different pieces? Sign goes. Rewrite that sign of X. That's not good. Let's work with these inside. How can I think of what can I do with cotangent? On the side, yeah. Cosine of x times tangent of x are two separate things, two separate trigs, functions. Cosine can make it stay, but it can convert tangent. Again, we're not touching the right side. We're really working on the left side and hoping and that's how we know we've ended the here. Keep working on one side until we get that side to look. Now that we're here, we can distribute through. Uh, so if I well actually distribute through, we're going to do it this direction here. Yeah, so I can save step. Now let's try to distribute the sine x through this. Down. Now the sine through. Sine, sine, sine. It's done because it matches. That's what we're doing for the next few days. Just working on identities, trying to play with one side, using properties, moving things around, try and work it so that it turns to number three. Cosine of x minus sine x squared equals 1 minus sine cosine x. We need some opportunities to expand this out. Start on the left side. You gotta be careful here. I just think that sine squared minus sine. We have to write this out twice. It's to do that, but if we do that, we're missing out on some terms there. So let's force ourselves write it as two separate parentheses. That's the first thing I'm going to do. I'm going to write it as binomial square. So now see if we can fill that out. Fill that out, see dust settles, and we clean it up. Hopefully get into it. So cosine times cosine. Okay. Know that we're looking at four terms, right? You can have written as sine x, cosine x. That's fine. The order is not going to matter. They're both still the same. Okay. It doesn't quite look like the right side. Do you see the properties that actually be useful? Anytime I see sine squared plus cosine squared, we know that there's some cleanup, some opportunity, right? We know sine squared plus then, what about these special? They're like terms, right? Find those two to get -2 cosine. So we're left with 1, 2 cosine. for. We'll start on the left side. We're going to try to make our way to the right side. Like I want a function to appear on the process. So let's start there. Go ahead and convert our tangent to secant to sine and cosine. Work out. Okay. Looking at the tangent then. Sine over. Oh, this is nice because the denominators are already matching, so we don't have common denominators. It's easier. There's some challenges ahead for us. So I have sine x plus 1 over cosine of x. Right? Always checking to see where our end goal is, right? We're not, we have something, like things are flipped around. So we have to create some situations that will hopefully bring us to what we want to. Now, this is one of those problems where you really can't use any identities, right? Everything's in sine and cosine, so how can we get this to a different form? So we're going to try to introduce something into the problem so we can force identity to show up. Okay, seems kind of strange here, but I'm looking at that cosine saying, well, what if I introduce cosine into the denominator? I can get cosine squared, I get cosine squared, and get some identity. But I can't just do something with the denominator without balancing it out. I'm going to try to introduce identity to the problem. Whatever I just did right there, also to the denominator. Basically multiplying. I haven't changed anything, but I create another scenario for me to. So denominator gives me cosine squared. Numerator, let's do the numerator factor form. I want to distribute that through because it's helpful to be separate. Denominator becomes what? Squared. Now, looking at cosine squared, thinking, okay, what if I just cancel these out? If I cancel out, then I'm back to 1. I want my denominator to show some version of sine. You can do that, right? Cosine squared, what can I do with cosine squared to turn it into and it's just math kind of moving in the correct. Okay with that jump. Okay. The reason why we're doing that is because we keep looking at our goal and we're not quite there. At least like the denominator showing the signs. I know that's I want to keep this in terms of sign. I don't want that sign squared there. Something that I can do to make this. Normally, we could do that, but it's standing in the way. Plus or minus, right? So, well, back factoring yesterday, difference of squares. So these perfect squares, right? Break it to perfect squares. I can maybe get something to match and cancel out a little better. So what does 1 minus sine squared x factor into? Let me write the cleaned up version. What do you see? You can pick this up a little bit more. That match? Matches. A little harder because we have to introduce something from force identity to show up, right? It didn't show up. Number 5. Okay, so take squared theta minus 1 over sine theta. Trying to reach our goal of sine theta minus sine squared theta. There's something that we can do. Does that numerator remind you of something? Never see anything squared. Either factoring stuff or maybe some identity. So this looks like I'm making much progress. The tangent helps to squared minus 1 is equal to tangent, right? Squared minus 1. Again, I'm just working side. Okay, I'm looking at the right side to myself. Okay, looks like everything there's a sign. So should I here get that tangent squared? Complex fraction dividing by the denominator is same thing as what? Right. So sine theta sine times 1 over sine. All right. Anything clean up here? One of the signs can go away. I'm left with sine over cosine squared. Are we quite there yet? Yeah. Okay, the reason why is because sine squared theta is another way of saying sine theta. Sine theta squared, same thing as sine theta. Whenever you see sine squared theta, that just means I have two separate sine thetas multiplying with each other. So that has to take off. Okay, what do you guys see here? Are we close? Looks like the numerator is good. That the denominator is somewhat here. I make the final adjustment. Substitution, right? This is my Pythagorean identity. I know that sine squared plus cosine squared is 1, so cosine squared is going to be minus sine squared. So I can jump. And submission there. Oh, sorry, sine theta, not sine squared. Okay, number 6. Start on the left side, move my way to the right side. All right. I want to try to merge those fractions together, but before I can merge those fractions together, so if you look, both denominators are completely different from each other. Keep both sets. So I'm just setting my common denominators, both fractions, and I'm going to put one of them. Okay, 8 is my first. Located between my second fraction and we're making some progress because we can merge them into the same fraction, add those two numerators together. So let's see here. What's 1 plus cosine plus 1 minus just 2, right? What I'm possible. So I'm just going to skip a step here and just say it's 2 over. It doesn't look like we're near the end, but the 2 is a good sign. Something that maybe yeah, let's just fold this out, right? Yeah, if we fold this out, we get a cosine squared to show up. Maybe an identity can come into play if we can find some other substitution to do. I'm going to fold this out here. 1 times 1 minus cosine x plus cosine x. It's basically a different squares, right? So it's just 1 minus cosine. I want to see all the terms here. I can do this. 1 minus cosine x plus cosine x minus cosine squared x. Anything standard here? What is 1 minus cosine squared x? Close to the end. 2 over sine squared x. Cool. What's that relationship? Reciprocal, right? So I can just push that sine squared up and equal. Okay, say it again, which part? Oh, why that 1 plus cosine x? Okay, so the reason why is because um, initially I created my common denominator. Now I'm asking myself, what do I need from my old denominator? What's, do I balance, multiply the numerator by either that old denominator? Anytime we're balancing our fractions, we're always comparing between our old denominator. Whatever's missing, we're going to multiply that missing. 1 plus cosine x. Number 6. Okay, number 7, sine squared minus cosine squared, 1 minus. Look at where we're starting. Look at where we need to notice here. Everything on the right side don't have everything. Very easy and quick way to convert. Diagram. Right. So usually you want to decide what to do. Sometimes it's kind of hard to plot, especially if you're a long ways off from your solution. But look at both sides and try to figure out what can I do to make it move towards one easy thing to spot. Everything's in terms of cosine, so try to start to make progress, try to move things in terms of cosine. These simulations there on cosine, I can replace sine squared with what? Cosine squared. If you're using a variable that you want to use x, that's fine. But again, you're only working on one side of your identity. We're not going to be adding to both sides, moving things around. Because that works. So let's keep cleaning up. Let's turn it. Drop the parentheses. Right, right. Number over tangent of b plus tangent b equals secant. I'm looking at the left side saying, okay, we've got some partial fractions here. Maybe I can find common denominator and start to push them together. What's my common denominator? Show denominators of both fractions. Let's see if we do some balancing here. Anything different between old and new? No changes, so any new things between old and new denominator? And B. We're making some progress. We can merge them into the same fraction. Things stand out. Hmm? And square. Right? We're moving the right direction. You can see it here, so we'll insert here. Any thoughts here? Say maybe leave the secant alone because we already have secants going up. But maybe let's put the tangent form that we cosine. It doesn't seem like sine or cosine is going to help. I have cosecant, but I think that is something that helps. Because if you think about cosecant, cosecant is related to sine. You know that we turn it into sine and cosine. no cosine related to secant, so it will help. That's tangent. So okay. Dividing by a fraction is that. Okay. This looks a little bit out of place, but is there a way for me to maybe get some secant to show up? What I'm thinking here. What's the relationship between cosine and what's the relationship between sine and cosine? Okay, so what if we push the cosine down and just call it secant? We push the sine up and call it cosine. We haven't changed anything, right? We make it move and we change its name. Same thing as saying we could do this. That if it feels like too big a jump to you, I always think of cosine as secant. You flip that, multiply by the reciprocal, that's the same result. So I'm just using my knowledge of sine and cosine, reciprocal, moving them around to get great questions that other here. Take out the secant. Let's get a head start into page 9. Why don't we just try to go for the first 4 problems? Now, these it's going to become more and more involved, but like I kind of walk you through every problem. Um, you understand the steps. Eventually, you're going to begin to recognize patterns. Do more questions. Okay. Okay, let's just do 10 more minutes. Okay, we'll stop after 10 minutes. Okay, number 1, secant of x plus 1 over tangent of x. I'll eventually turn that into sine of x over 1 minus cosine of x. I already see something that I can do. Let's see any ideas. Do at the beginning, knowing that we're starting on the left side and wanting to end on the right side. Get everything from the sine and cosine. It's going to be a little ugly in the beginning because we're going to deal with some complex fractions. But I think that's my step. We can quickly get that secant and tangent to be sine and cosine, and after clean up, we'll see yes. Okay, so secant can be rewritten. Okay, now carefully, it's going to speak in this numerator section, my complex fraction. I'm putting a 1/1 there just so I can know that I gotta work in the common denominator here. Okay, how about tangent? Okay, we have an added complexity here. We are going to bring that denominator to the top. We are going to multiply by the reciprocal, but we need to handle this numerator. We want this to be a little cleaner. Okay, so we're going to kind of step aside. We're going to get that numerator into a common denominator, one fraction, and then we can work in the reciprocal out that sine over cosine. We're going to step to the side and we're going to do this problem. Just be a little cleaner. Otherwise, when we bring this up, it's not going to be easy canceling out. We want this little. So stepping up to the side, what's the common denominator of the portion? The side here, I'm going to use the space. My common denominator. Okay, between my old denominator and my new denominator, my first fraction changes. No, bring one down. Between my old and my new denominator, are there any changes? Cosine. Cosine. This is good because now we can rewrite this fancy this in a lot better form here. Now we have 1 plus cosine over cosine. We got it down to a fraction. A little cleaner with our. So now that I have a clean fraction over another fraction, now we can do the multiply by the reciprocal. So I'll take this, multiply by the reciprocal. Mm-hmm. Against, not against. Okay. This is one of those problems where you have to introduce trig identity, maybe assign x to get something. Let's just finish this problem. Okay. Won't hold you past. Super long. We know we're at least we're in the same trig function. Dealing with out of place. We saw this before, right? We know that we can get that sine, we turn cosine, we can get it to be a sine squared. This is similar to the last problem that we did, where we find the problem in the hopes that the trig identity can. Sine squared looks familiar. Right? Denominator to at least match. We'll this looks familiar from the previous problem. With that one minus cosine squared. We factor, we can get that, get this 1 plus cosine. Okay, good. We'll stop there. You guys keep your worksheet out. I just want to see your finish line. Is there a question?